Hello class, this is Professor Choi. Today we're going to have a quick conversation about what exactly is a continuous probability distribution, and in very particular case, what is a normal probability distribution. So a continuous probability distribution, remember, is a distribution where you get probabilities on the y-axis and then you get some kind of number or quantity on the x-axis. Okay? So the probability of x being the number that's there, alright, then you have a distribution, something like this. Now a continuous distribution is a distribution that has no gaps. So it could be something like a rectangle, it could be something parabolic, or it could be something like that kind of ends there, or it could be something like a normal probability distribution. Okay? Now what we're doing today specifically is giving you a bit of a refresh of the empirical rule, because normal probability distributions are heavily used to study a lot of things, because somehow it tends to show up in a lot of places that things have a normal probability distribution. I don't know if you have been following, especially for the year 2020, and I'm not sure how long this video is going to be on the internet, but if you follow the distribution of, for example, the fatalities of COVID-19, you're going to notice that it has this very sort of not normal. Now, but if you look at the amount of cases, for example, that has a more of a normal look. So there are particular distributions that have this normal look, and a lot of things in life seem to follow this normality pattern. Alright? So anyway, we're going to talk about this because it's a fairly common distribution, and if in fact you find that something is a normal distribution, then there's a lot of quick math that you can do with it that's really useful. Okay? So a normal probability distribution, it's a bell-shaped distribution. In other words, when you graph it, it looks like a bell, as you can see here. It is symmetrical, which basically means that it's split in half by the mean. So if I were to kind of like slice it right here, you will get two exact copies on each side. So this side is an exact copy of this side. Alright? Now, it is also asymptotic. What that basically means is that when we're going towards the end, it never really reaches zero, but it approaches ever so slightly to that zero. Alright? So it's kind of like it gets there, gets there, gets there, but it never really touches that zero. It just keeps getting closer and closer and closer and closer. Alright? The mean, the median, and the mode are equal. And that's basically the biggest telltale sign that you have a normal distribution. The mean, median, and the mode are all basically the same number right there. And of course you get the bell shape. Alright? And the total area under the curve is 1. Now, this right here is what we call the empirical rule, or the explanation of the empirical rule. Now, imagine, for the sake of argument, which is to kind of like understand this example, imagine that I tell you that we found that the mean of a distribution is 70 with a standard deviation of 10, and we found out that the distribution is normal. In other words, it exhibits this list of characteristics that are here. Alright? Now we find that out, then one of the cool things that you could do with it is some very quick probability math. And in this particular part of my statistics, we are talking about probabilities. So with the empirical rule, you can quickly figure out some probabilities, assuming that something is normal. So if the mu is 70 and the standard deviation is 10, we can basically be very certain that 68% of the data points are going to be within 60 and 80, or also known as one standard deviation away from the mean. One standard deviation away from the mean is the same thing as saying mu plus or minus 1 sigma. So mu we know is 70 plus or minus 1, 10. You're going to find 68% of the data within those two spots. Alright? Now, to kind of relate this to real life, imagine that these were grades. You know, these were student grades. Alright? So these are student grades. What this basically means is that 68% of the students scored a grade between 60 and 80 with this distribution. Okay, now, 2 standard deviations away, and 2 standard deviations away is the same thing as saying mu 70 plus or minus 2, and in this case 10. So 2 standard deviations away, you are going to find 95% of the students. So between the grade of 50 and 90, you're going to find that 95% of the students are between this grade 50 and 90. Alright, then 99.7% of the students are going to be found between mu plus or minus 3 sigma. So they're going to be found between 70 plus or minus 10, plus or minus 3, 10. So in other words, between the number 40, which is 30 away from mu, and 100, which is 30 away from mu. Alright? Now, imagine that we wanted to calculate the probability of something, which is really what this is. Alright, now, using normality, if we have those numbers, there are particular probabilities that can be easily calculated. Alright, let's come up with an example. So let's come up with a question. Let's say, what is the probability that someone scored higher than 70? Alright, so again, imagine for the sake of argument right now that these are test grades. So these are test scores. And now we found out that the mean test scores was 70 and the mu was 10. Somebody's asking you, what is the probability that someone scored higher than 70? Alright, now if we know that 70 is the mean, and we know that this is a normal probability distribution, then we know that we can slice that 1 in half. So in other words, half of the students, or 0.5, are going to be to the right of that half, and half of the students are going to be to the left of that. So if they're asking us for what is the probability that someone scored more than 70, what they're asking us for is the area under the curve higher than 70, because 70 is the mean. We know that the answer is going to be 0.5 or 50% because of the empirical rule. So we can tell immediately that the answer is half the students because of the empirical rule. Alright, let's come up with another example. So let's say, what is the probability that someone scored higher than 60? Okay? So what is the probability that someone scored higher than 60? Well, in this particular case, we know that higher than 70 is 0.5. But then how much is higher than 60? Okay, well, let's check it out. We know that this area is going to be 0.5. But we got to do from 60 all the way there. So we're missing basically this portion here. All right, now how do we figure that one out? Well, look at this 68 here. One of the things that we could do is we know that one standard deviation away from the mean is 68%. But because it's split in half, that's the same thing as saying 34% to the right and 34% to the left. That's 68%, correct? So that basically means that we know that this x right here is 34% or 0.34. Therefore, the probability that somebody scored higher than 60 is the same as 0.34 plus 0.5 or 0.84 or 84% in this particular case. All right? So somebody says, what's the probability that somebody scored higher than 60? And you get this breakdown, then the answer is the area of the half plus that little section there. We know that one standard deviation away, you have 68%. We can split that into 34, 34. Therefore, we can say that this portion here is 34%. Okay? All right, let's do another example. Get this green away. I need that in a second. All right, now let me get this kind of split. So we know that this is 34% here. We know that this is 34% here. All right, and we know that this is my mu. Now let's split this 95 here using that 34 already. Now, we know that 2 standard deviations away you got 95%. And we know that this portion in the middle of this 95 is equal to 68. So I can take and find these 2 portions here as well. And I can do that by doing 95% minus 68. And then whatever I get there, I divide it by 2. So I'm going to do 95% minus 68. That gives me 27%. And then I'm going to take that 27% and I'm going to divide it by 2. So 0.27 divided by 2 is 13.5. So 13.5% is what goes there, and 13.5% is what goes here. Okay? Now if we're going to split it all the way to 99.7%, then we can find what you put on these sides, which is the difference between that 99.7 and this 95 divided by 2. So we do 99.7. Oops, made a boo-boo with my calculator. And then divide that by 2. So this here is going to be 2.35%. And this here is going to be another 2.35%. Alright, again, because of the empirical rule, during these particular points, we can calculate probabilities very easily. Now, other probabilities might be a heck of a lot harder, but the ones that are like right there between a mean and a standard deviation are fairly easy to see. Okay? So, let's find out another question. Imagine that somebody asks you, what is the probability that a student got a B? And the definition of a B is between 80 and 90. Alright? Now, let's obscure the example, by the way, where it's like, well, you know what, let's do 89.9, okay? There you go. So between 80 and 89.99. Okay, now, you might be able to calculate the specific number here, but we want to come up with something fast. So, we know, because of the empirical rule, that this area here is exactly 13.5. Therefore, the probability that somebody got a B is 0.135 or 13.5%. because it's between 80 and 90, which is right here. Okay? Let's do another one. Let's say they ask you, what is the probability that a student scored between let's do 40 and 60. So what is the probability that a student scored on their test between 40 and 60? Alright? Now, the probability under a normal distribution, again, is the area under the curve. The probabilities are these numbers that we found right here. So if we're looking for what is the probability that a student scored between 40 and 60, what we're basically looking for is we're looking for this area here. Because these endpoints fall exactly where my empirical rule explanation shows up, then all I gotta do is I gotta add those two numbers. So the probability between 40 and 50 is 2.35%, or the same thing as 0.0235. And then we gotta add 13.5%, or the same as 0.135. And that's our answer. 2.35 plus 13.5. And that gives us 15.85%, or 0.1585. And that is the answer to what is the probability that a student scored between 40 and 60 on this test. Now, again, because these are random variables, remember what we're basically trying to say here. Now, imagine that I would close my eyes and I were to grab a student in my class, and this is a distribution of that test. Then what this is basically saying is that 15% of the time I'm going to grab somebody who scored between 40 and 60. That's what this probability shows. Alright? Anyway, I have more videos explaining continuous probability distribution, especially the normal probability distribution, and it starts getting a little bit more complicated from here. This is using the empirical rule, which is an excellent way of coming up with quick probabilities for stuff. As you can see, pretty easy to calculate. Alright? Thank you for talking to Professor Choi today, watching our video. And if you like my videos, remember to subscribe to the channel. Have a good one.